I'm Isaac Portillo, and for my final project, I created Conway's Game of Life in Java. And what Conway's Game of Life is basically an automaton. It's a zero-player game, so that means that the end state of the game is determined by its initial state, and it just follows a set of rules. I have them here on the Wikipedia, but um, any life cell with fewer than 2 live neighbors dies as if by underpopulation. Any life cell with 2 or 3 live neighbors dies or lives on to the next generation. Any life cell with more than 3 live neighbors dies as if by overpopulation. Any dead cell with exactly 3 live neighbors becomes a life cell as if by reproduction. And um, these are really simple rules, but really complex patterns can rise from this. It's like watching a little ecosystem grow. Um, but it will always eventually decay into a stable form. But going to my code, this is the cell, and what this is just basically represents like the state of all these cells in the grid. It's like a little checkerboard sort of thing. But this is just for each square in the grid. Each cell by default is dead. These two, the kill just kills the cell. The birth, what's it called? Basically just makes it alive. And these are self-explanatory. And then grid. So grid is a 2D array of cells, or in grid there is a 2D array of cells, and this represents the grid as a whole. So this just populates the entire grid with dead cells so that we have something to work with. This will fill it with random cells, so half of them, or about half of them, will be alive and about half will be dead. That's if I'll get to that later. Load preset, I'll also get to this one later. Visualize cells, this was for, I use this for testing and debugging before I got my GUI to work, because I didn't really know how to use Java Swing and AWT and stuff like that. But what this does is basically go through the array and then display them as either alive or dead, black being alive and white being dead. And it just do that to the console. These are all self-explanatory. And then neighbor grid. So this basically just keeps track of the next generation. What's this? Anyway, so generate next. So these are the rules I established that I went over here. But what's it called? Yeah, this will just go through it, and according to the rules, it'll create a new one. But in order to do that, it needs to know how many neighbors each cell has. So each cell has 8 neighbors, and so what I do here is I have basically just positions relative to the center, which is the current chosen cell, and it'll go through it, and it will count up all the neighbors, and then with that information it can generate, or you know what the next generation will contain at that space. Visualize neighbors, this is the same as what's it called, the grid. And getter setters. What else? Here. Okay, so I did cell, grid, neighbor grid. I'll do game panel. Yeah, so this basically contains the graphics, or what controls all the graphics for the screen. So we have width, height, grid size, stuff like that. Paint component, This will basically just draw everything to the little canvas area, the grid lines. Um, this will make it turn it into a, what do you call it? Like a checkered paper, not checkered paper. What, I don't know what I'm saying, but it draws grid lines on the page, given the unit size and uh, the width and height in units. And here I have, I don't know what this does, but IntelliJ wanted me to add this, and it wouldn't run without it. This here, whoops. So this here will get the coordinates of a mouse press, and at that wherever the mouse is clicked, it will actually change the state of the cell to the opposite. And so you can use that to interact with the game of life while it's still going. Fill screen. So after every generation, instead of drawing over everything, it clears the entire screen, and then it redraws, and then it draws the squares where they need to go. Change cell, this just changes it to the opposite. These are all, yeah. And then that game frame is basically just stuff with a window. And then game of life. So when you start this, I probably could get rid of that. It has a little dialogue, and so I have this fill random where you get to customize pretty much everything except for where it goes or where you can click them. I tried to add a little thing where you could click them, but it didn't really work out very well. So you can't really have anything custom, but it's all right, I guess, because these are pretty cool. But yeah, fill random will actually, I could just show them. So, or I should actually explain my code first, but yeah, it's the little dialogue thing. They're all different depending on which preset you choose. Oh, also presets. These are just the ones representing alive cells, zeros representing dead cells, and this is just like a little starter seed for cool little patterns. But place pattern, this will just place it wherever you want the pattern to be in an empty grid, so that you don't have to have like tons of zeros. Yeah. But back to here. So it has all this. Grid to keep track. So this is just a sort of placeholder thing for the neighbors. Fill neighbors, that's kind of the same as the fill grid thing. Game frame, this will make a new window. Here, like a new window. And I don't remember this actually. I'll have to go back to that, but I have this function here called nap. I named it that, and then I just decided to keep it that way, but this is just delay. So if you enter the number of generations per second, it'll divide that by 1,000. So if we lived in a perfect world and I was just like a perfect coder, and it ran instantly, this would hold true to its name, but that's really just how many slices of a second, how many fractions of a second. I don't really know how to put that, but it just makes it, it adds a little bit of delay so that you actually get to see what's going on in the program. Update, this will just redraw everything, and then generate the next generation with, or given the current state of the grid. And an example of this, or I'll get an example going. So, fill random. We'll do, let's go 30 generations per second. 300 and 600 columns, and I'll do a size of, let's do 3. It's kind of big, but yeah. You're able to click on them, and it will, you can interact with them. And in this, you can see stable patterns arising, and like this little glider gun, that's pretty cool. But yeah, and I like the presets. So another one, Arpentanimo. This is one of like a big generation from a small starter. You get the point. The Gosper glider gun, that one's pretty cool. We'll do 40. So this will generate glider guns and just like shoot them out. It's like a little factory. What else? Okay. I'll do 100 just to speed it up. Yeah, with their low gliders, and it decays into a period 3 pulsar. I bet I could click on it and mess it up. Yeah. And I like the little fella, because he's a little guy. He decays into a glider gun, but I won't show that because it takes a bit. If you'd like, you can do that on your own. But I have one more preset, and it's just the puffer train. I could have left it as just random everything, but this is kind of fun to watch. I think it's like the stimulating TV shows that little kids watch, but for big kids. And yeah, that's about it. Thank you for watching. Goodbye.